Hello everyone, I'm Yash. In last video we saw how to install drivers for USBasp using Zadig. In this video I'll be showing how to upload a program to your microcontroller and make it complete some task. So as for beginners, I will be doing a blinky program, that is I will blink an LED for an interval of 1 second. Like it will go on off for 1 second, go on for 1 second, and then go off for another 1 second, and so on. So before we can write a program for our microcontroller, we need to make a setup environment. We need to set up an environment for developing a code. So I will be discussing that as well. So without wasting much time, let's get ahead. As of using development environment, I will be making use of Atmel's own Atmel Studio 7. That's because it's easy to install as it is based on Visual Studio. Also, it provides support for most of the microcontrollers that are developed by Atmel, including the 8-bit microcontrollers, the 32-bit microcontrollers, and the ARM microcontrollers. So if you want to use any different compiler like the WinAVR compiler, you can also use that. The WinAVR package also includes AVR dude, which we'll be using for uploading our code to the microcontroller. So I will post the links for Atmel Studio 7 as well as WinAVR in the description. You can just download them from the using the link. The Atmel Studio setup is available in two versions: the web installer as well as the offline installer. The web installer is of around 2.3 MB, whereas the offline installer is of around 878 MB or something. The WinAVR package is pretty small as compared to it. It's of around 30 MB again, if I remember right. So that's it for the setup and setting up an environment. It's easy to set up. You just have to double click and follow the instruction to install. You don't have to set up any environment paths, as the setup will do it for itself. That saves the trouble of setting up environment variables and all. Now that I have installed Atmel Studio on my computer, I'm ready to write the code for my microcontroller, that is ATmega328. So let's get started. Now, so Atmel Studio 7 is getting started. Starting. You see, this is powered by Visual Studio, so it is, as I told you earlier. Okay. Fine. So meanwhile the Atmel Studio is getting started, I will just show the pin mapping of ATmega328 or 328P. ATmega328P powers the Arduino Uno board. So these are the Arduino functions. Each pin has the Arduino function of its own: analog input 5, analog input 4, analog input 3, for analog inputs. Then there are these digital writes: digital pin 13, digital pin 12, digital pin 11, and so on. But the actual pin configuration of the microcontrollers are given as PC6, PD0, PD1, PD2, and so on, where P states the port, C states the name of the port, and 6 or the any integer value, that is 6, 0, 1, 2, 3, 4, defines the pin number of the port. So the PC6 defines that it's the pin port pin. No, I can't put it that way. Okay, I will put it like this. Port C and pin 6, or let's say bit 6 of the port C. So that's how it can be read, like, or the PD0, which states that port D pin 0, port D pin 1, or also known this these pins are also known as port pins. Okay, seems like my Atmel Studio has started. Before doing that, let's blink the LED on DigitalPin13 of Arduino, that is the pin PB5 of ATmega328P, which is also an SCK pin in case of SPI communication, that is serial clock, which we will be also using the SPI interface for programming our microcontroller. Okay, let's move to Atmel Studio. Okay. So this is the welcome page of the Atmel Studio, where you can get getting started with Atmel Studio provides you with the complete documentation of Atmel Studio, which is very helpful if you get stuck somewhere. Then there's it getting started with the AVR development. The AVR development series is developed by microchip, and it's pretty easy to understand if you have a development board like AVR X Mega and all. Then getting started with open Atmel start configurator, blah blah blah. You can also download different Atmel Studio extensions, like there is an extension for Arduino which helps you for developing your Arduino code within the Atmel Studio itself, so that even if you don't use Arduino IDE, that's fine. Okay, so let's get write a program to blink an LED. Okay, go to file, select new project. Now we will be using C or C++ language, since I won't be using assembly language or Atmel Studio solution. So C, C++, then select GCC, C executable project, name your project. I am giving it blink. Also create a directory for solution, yes, because there will be lots of files generated once you compile your code successfully, which will also include the hex file. The hex file is the actual file that we will be uploading to our microcontroller. You can select the location of your directory. I have chosen to save it on desktop. Okay, device. Now comes the device selection dialog box. So as you can see, there are lots of microcontrollers from Atmel. But the one we are looking for is ATmega328 or 328P, or 328PB works fine as well. So you can just find it by selecting the device family. Now we know that it is ATmega, so choose ATmega and look for the ATmega328. ATmega328, 328, yeah. Here it is, ATmega328, 328P and 328PB. Or you can just also search it from the search box, ATmega328. So this shows all the three of them. Okay, now I'm selecting ATmega328. Okay, check blank. So this will create your project. It will also create a directory of the name blink. I will show you. There is blink. Okay, so this is the directory blink where my project has been created. Okay. Once the project is created, a main.c file will be generated. That's the file where you write your main code, or the code you want to execute will be compiled from the main.c file. Now, before getting started to code, first decide the what frequency you will be using for your microcontroller. Now I am selecting a 16 megahertz crystal, so just select the 16 megahertz. You need to define the frequency at which you will be operating your microcontroller. So let's just define FCPU. Define FCPU 16 megahertz. So this defines my CPU frequency or the crystal frequency. Now hash include avr/io.h is the library which includes the basic pin configuration for all the IOs available on an 80 mega microcontroller. Now since we also need to use the delay to blink an LED at an interval of 1 second, we also need to include the delay library. So hash include utility/delay.h. This loads the delay library for me. Now coming to the main loop. In the main loop, whatever is written outside the while loop is executed only once, whereas whatever is written inside the while loop, it gets executed forever. So the code we need to execute only once is like to use the pin as an input or an output. Let's say now we need to use the pin 13 or digital pin 13, that is pin PB5 of the 80 mega microcontroller as an output to blink our LED. So let's just set the PB5 pin as an output. In 80 mega microcontrollers, each pin, or let's just say in any microcontroller, each port pin has three registers, three register bits. The DDXN, that means the data direction register bit, which defines if the pin is to be used as an output or as an input. Then there's the port pin, which defines the pin number, that is the PB5 is the port register, and then there's the pin register bit. Now if I write the D1 to the DDXN bit, my port pin will be set as an output. If I set it to 0, it will be used as an input. Yeah, see, it's written in the configuring the pin. If the port XN is written to 1, when pin is configured as an input pin, the pull-up register is activated. To switch the pull-up register of port XN has to be written to the 0. Like, if I am using the input as an let's say if I'm using the port pin PB5 as an input and I write 1 to it, then it will be set as an pull-up input. So it's like if I want to read the button, then I have to ground it so that the microcontroller can detect that the change has been occurred on the pin. Okay, okay, fine, I will just show it by programming, writing the code. Now I have to set up my PB5 as an output. So DDR B. So data direction register for port B is to be set as an output. Okay, now PB5, that is the fifth bit of the register, so I need to set PB5 as 5 as 1, that is the fifth bit of the register as 1. So 0 1 2 3 4 5 6 8, yeah, 8. So 0 1 2 3 4 and 5. Okay, this sets my PB5 pin as an output. Pin PB5 as output. Okay. Now I have to write the value to port register. Like, let's say, to make the LED blink, I have to write the value to the port register. Okay, so port B is equal to 0 0. Okay, this sets my microcontroller's port PB5 to high, and then again I will keep it on for a 1 second delay, so I will be using DDMS. You can also use a delay microsecond if you want the delay in microseconds. So for in microseconds you just have to replace the M with U. Okay, but here I will be using M milliseconds. 1000. Now after 1 second I have to turn my LED off, so I will shut the pin. I can't say shut it down. I will set the PB5 pin to 0, that is 0 volts. So port B is equal to 0 B 0 0 0 0 0. Where should it go? 0. Okay, then I wanted the LED off for next 1 second, so again delay, I will have to use the delay of 1 second. So what will go on is my LED will be continuously glowing on for 1 second, then it will go off for another 1 second, then once it reaches the delay of another 1000 seconds after going off, then it will once again go to the first line of the while loop, that will set the LED on again, and so the cycle will go on and on. Now that the code is complete, let's see if it can be compiled. Go to build and click on build solution. Filing. Okay, finish building. Yeah, build succeeded. That means my code doesn't have any errors and it is ready to get uploaded to the microcontroller. Alright. Once you have compiled the code, you will also get the hex file generated in your solution directory. And just go to the blink and then go to debug, and you will see a list of different files generated: blink.ep, blink.enf, and blink.hex. We need the blink.hex, that is to be uploaded to the microcontroller. Okay, now let's move on to uploading our code to the microcontroller. Now that we have compiled our code successfully, it's time that we upload it to our microcontroller and make the LED blink. Before we can upload it to the microcontroller, just make sure that you have already installed the AVR dude from the WinAVR package, as well as installed AVR dudes. Now I'm recommending AVR dudes because it's easy to upload the hex file to your microcontroller using the GUI. It's a GUI for the AVR dude, so you can't use AVR dudes without AVR dude. It's developed by Zach Campbell and it's pretty much easy to use. Also, it's a small package of around 1 MB, less than a 1 MB actually. And but just make sure that you also have a .NET framework as well. So just download it from the website and install it. Now I have already installed it on my computer, so I won't be installing it again. Okay, once you have made sure that AVR dude is installed on your computer, open a command prompt window and just type AVR dude. If it has been installed successfully, then you will see the AVR dude version as well as the list of some commands that can be used, list of the para options that can be used while using AVR dude. Now about assembling the circuit for your microcontroller. I will be uploading this circuit diagram that is basic powering circuit diagram that can be used to upload your program to the microcontroller. As of me, I have made a small development board for myself and it's worked pretty fine. I have hooked my USBasp to the development board itself, so this saves me the trouble of building the circuit on breadboard every other time. All I have to do is hook up my USBasp to the computer and then just upload it to the controller. It's quite pretty easy to build. I will also upload the schematic files for this development board as well as the circuit. This circuit is pretty easy. All you have to do is uh, connect the crystal to the PB6 and PB7 pin, that is pin number 9 and pin number 10, and connect the 22 PF capacitors, ceramic capacitors across the crystal and the ground. Give another capacitor. You can use an electrolytic capacitor to avoid noise between VCC and ground. Give a 5V supply to the VCC. Also, don't forget to use a external pull-up 10K resistor for the reset circuitry. Okay, this is the circuit that you need to assemble on the breadboard, or you can make its PCB and then use it to upload your program to the ATmega328 microcontroller. Okay, now since I already have this development board, I will just connect my USBasp to the computer and upload my program to the controller. Okay. I'm starting the AVR device. AVR device is started. Now first select the USBasp programmer in the programmer option. You will find it on the as the fourth last option, or the fourth from the bottom, USBasp. Then if you are not sure which microcontroller you are using, like if you are not sure if it's an ATmega328 or ATmega328P or ATmega328PB, just hook up your microcontroller to the USBasp and click detect. The AVR device will do it for you. and detect the microcontroller you are connected. Now it has detected that my microcontroller is 80 mega 328. Also make sure that your circuit is the circuitry on your breadboard is doesn't have any loose connection, because it might get through an error if it is not able to communicate with your microcontroller properly. It might also show that the device signature isn't matching on that. Now I have to upload my program to the microcontroller, so I will load the hex file in this flash option. Okay, build desktop link.hex. So it's taking only 178 bytes of memory, and now I will click on go, or you can also select program that will write down blink.hex to my 80 mega 328 microcontroller. Okay. So it's a very quick process depending on the size of your program. Now 178 bytes isn't much, so it happened in a flash of second. So verifying is done, and that means my reading verified is successful. So that means my program has been successfully uploaded to the microcontroller. Okay, now I will hook up an LED to the microcontroller. I will just focus my camera. PB5. Now this is the LED I will be blinking. Okay, now all I have to do is here goes pin 13. Pin 13, that is PB5. Okay, PB5 is pin number 19 on my microcontroller. So 15, 16, 17, 18, 19. Here it goes. My LED is blinking at an interval of 1 second. So this completes the uploading this completes how to upload your program to the microcontroller using the USB ASP. It's quite easy. If you are stuck somewhere, you can just put your queries in the comments, and I will make sure to reply as soon as possible. I will also make a tutorial about this on my blog, so and post it on the link, so post it in the description, so you don't be having any trouble. Also I will share the links for downloading Atmel Studio 7, WinAVR, EVR Dudes, as well as the datasheet for 80 mega 328. And if anything that I found will be useful, I will share it. So with this LED blinking, this tutorial of uploading a program to your microcontroller is completed. Hope you like the video, and thank you. If you like, please do share it, subscribe the channel, and hit like button. Thank you. Tada, bye bye. See you. Okay.